Hello everyone, welcome back to the channel. Let's continue implementing core module of our application. We have implemented models, so all we have to do right here is to implement the mapper. I'm gonna get you up and running how to define mappers in the C#, which is very simple. And we're going to use again extension functions, a little bit different than the other languages, if you will. Let's do the most easiest one, which is for the application settings entity extension function. First of all, create a new class. It will be on application settings entity. All right, make it public. You have first of all to create a new class, mark it with static, and for readability purposes, add extension. It doesn't matter if you don't do here extension or not. And to make the extension function that we're going to call it to application settings, mark this function with static as well. That should return application settings. The name of the function is to application settings. As a first parameter, we have to pass this as the first argument, application settings entity, and let's call it entity. It's gonna return new record, application settings for is dark mode equal entity is dark mode, latest visited route equal entity and latest route. As simple as this. We're gonna see how to use this extension functions under our code when we're going to implement the stream user as well as stream application settings. With the same manner, we need to define the application settings extension function on application settings model. Convert from the model to the application settings entity when we're going to basically save new data. I'm going to copy this under the same file. We don't care. Application settings, instead remove entity. It should be on the model. All right. The first one, the function should return application settings entity. Let's name it to application settings entity. The parameter this, and it should be on a type of application settings model. Name it model, if you will. This will return application settings entity. For the ID, as usual, I'm gonna assign here 0 as first ID because we're gonna have only one record representing the application settings. Is dark mode, model, and is dark mode, latest route, model, and latest route. Save the file, and that's pretty much it. With the same manner, we're going to define the extension function on image entity, image model, and image DTO for the different conversions. As usual, we're gonna have the image entity from the entity to the model, which is very simple, and all the other possibilities that we have defined under the other applications. Let's create an extension function for product. I'm going to change this to application settings mapper and this to products mapper. As usual, we're going to convert from the model to the entity and from the entity to the model. We're going to assign the ID, title, category, price, and description, and media. We have to get the media from the entity and media. If it's null, it's going to give us an empty array. Otherwise, we have to convert the media accordingly. Entity and media select for mapping. Let's name this to image entity and to image. As you can see here, we have used the to image mapper to map from the entity to the model. As you can see here, it's pretty straightforward as we normally would in other languages. With the same manner, we're going to define from the DTO to the products entity. I'm gonna group it under another class, products DTO extension, just to keep things organized. All the stuff related to the products model are grouped under one class, and all the stuff related to the products DTO are under one class. For the other function, from the DTO to the model, with the same manner that we have done earlier from the entity to the model. It's worth mentioning for the price, it should be explicitly converted to decimal. For the model, we have the decimal representation for the price. Under the DTO, we have double. Therefore, we have to make the conversion from the double value to the decimal. The last extension function, it's going to be for the preview DTO. Once again, from the preview DTO to the model. It's going to be under a dedicated static class when we have to make the conversion from the double value to the decimal value. Let's create the mapper for wishlist. The first mapper should be from entity to model and another extension function from the model to the entity. Therefore, every time you have to create an extension function, you need to create a static class to represent the extension function. And the key here is to do this referring to data type to which this extension function should be applied to. Next, we need to convert from the model to the DTO. We're going to assign the ID and product's ID, and we have to assign the product detail from model and to product. You have here two options, either to add another DTO under the products mapper, or just to do it directly by doing product DTO. Now for the ID, it is model and products ID. And for the title, if it's available, gonna assign it from product detail. Otherwise, it's gonna be empty string, as been suggested here. Likewise, for the category and price, for the price, we have to convert from decimal to double. It should be nullable, all right? I'm going to use the model, product detail, and price. If the whole value is null, we're going to assign 0.0. The same goes for the quantity and description. If it's null, we're going to assign 0, otherwise from the product detail. For the media, it's a little bit complicated. We have to convert from the media from product detail to the model by doing model, product detail, and media, and select. Let's name this to image from the mapper. Otherwise, it should be empty array. I don't think that we can use this. Therefore, we have to create it explicitly from doing image, DTO, and we have to assign the unique ID, file name, original, and preview. And you have to explicitly use image DTO. And of course, if the value is null, we're going to assign empty array. Now, with the same manner, we're going to create the extension function that's going to convert from the DTO to the model and from the model to the entity. For the first one, to wishlist item, that's going to convert basically from the DTO to the model. And for the other one, that has to convert from the DTO to the entity, and we have to provide the user ID. And it will return wishlist item entity and pass in the user ID from the parameter. For the user mapper, it's not that complicated. For the first extension function from the entity to the user, it's not that complicated. And we have to add another extension function from the DTO to the entity. We need to provide the ID, name, email, and email verified at, which is basically a date time. We have to do DTO and email verified at, and we have to convert this string to date time. Therefore, under util package, I'm going to create under util package another folder. I'm going to call it extension. Under extension, I'm going to create a new class. I'm going to call it string extension. It has to be a public static class on date time. That should give us a date time nullable value. Let's call it toDate. This representing the string. Let's call it value. I will try to parse the string representation to the date time by doing if date try parse, otherwise it's gonna return null. As the first argument, the value, next the format, and we have to pass here the culture info. We are not interested in this, date time style none, and the output variable, which is correct. This is good. I'm gonna call it date. This is the output variable that this function toDate is gonna yield, date. I think that we have to use try parse exact. It's the correct one. And of course, we have to maintain the naming convention by doing here uppercase. Now let's come back to the user mapper. And here we have to do toDate. The same for the conversion from the user DTO to the user model. The last mapper that we have to implement, pagination response mapper. First of all, we have to create a static class. Let's call it pagination response DTO extension. That's going to convert from the DTO to the model of type pagination response model. And the name of the function is toPagination response. The return type is pagination response. And we have to pass here the first arguments. It should be model. You can name it whatever you want. And as generic type, we need from the DTO to the model. For the first parameter, it should be this and pagination response DTO, because we're going to convert from the DTO to the model. And we have to pass here the DTO, generic type, and DTO that should be used inside the implementation. And the second parameter, it should be a callback function that's going to allow us to convert internally under the select function. We can use a function from the DTO to the model. Let's name it selector. Will return new pagination response of type model. For the data, we have to use an array from the DTO data select, and we have to pass here as an argument the callback function selector. And for the rest, it's pretty self-explanatory. With the same manner, we're going to create another static class that's going to represent the extension function to convert the search pagination response DTO to search pagination response model. And that's all we have for the mappers of our application. Now let's come back to the implementation of the database, and we have to implement the stream of data and the stream of application settings. Underneath, I'm going to create here a public function, iObservable of type user and nullable. It's pretty self-explanatory. The user can be null if there is no authenticated user at the first time we are going to run the application. The name of the function is stream user. First of all, we're going to preload all data for users and their relations by using a function user data query. This is very important. It's going to load all the needed relationship. Next, you have to observe changes in the local user data. Let's store it under local users, calling user entities and local. And we have to return the user observable as observable, and we have to map it to user model. By using select, we're going to obtain a list basically of the emitted values. We have to convert this list to the model, all right? And we have the user here. Let's pass user and let's use the mapper to user. In this list, we're going to only get the first or default. This is going to allow us to map from entity to domain model. And if you do remember, under the Kotlin and Swift application, we have used a class that has been called resource. I'm going to do the implementation of the resource class that we have used under Swift and Kotlin. Under util, create a new folder. It's going to be for API. I'm going to place this under API. Create a new class. Let's call it resource. So in C#, we don't have the sealed class, and the enum under C# are not too powerful compared to the enums under Swift. Therefore, we have to come up with an analogy somehow. And what I thought about actually is to use abstract class. It has a generic type of type T that has a primary constructor, nullable T. Let's call it here data. And it has a nullable exception. It has a member, data, as well as exception. And we have empty and loading and success and error. Let's define the first one, which is empty. It is sealed class. It does have nothing to do with sealed class and the Kotlin. Basically, the sealed class under C# can't be inherited. Empty of type resource of type T. And for the public empty, it has a constructor basically from the parent one, default and null. Next, for the loading state, a sealed class of type resource of type T. For the suggestion, instead, this is not what I want. I'm going to delete this. Here it should be a type nullable type T and data equal default and of type resource. All right, I think that I'm going to do it like this. Of type T, the nullable value data equal default resource of type T. And let's open this parentheses and do here data and do here data and null. With the same manner, we have to define the success state for resource. For the data, it's mandatory. Now the last case for error, nullable T data equal default and the exception, nullable exception equal null. The default value, all right? It should be of type resource, of type T, data to the constructor, and exception. I'm gonna override the function toString for debugging purposes. I would like to show the type name, either loading, empty, success, or error, followed by the data, and if there is an exception. We can get the type name by doing, let's start under type name, get type and name, and let's convert the data to string equal data. If it's not null, we have to do here data and toString. Otherwise, we'll assign, and because the conversion of toString is nullable, we have to do here another string for null in case if we have null from toString. Now for the string representation for the exception if it's not null, we're gonna assign exception dot message. Otherwise, it's gonna be null, which is correct from the suggestion of autocomplete. Now we have to return the string representation. I think it's correct, hands down. This is a good representation of the toString method and the resource. And for the record, you can use this resource as you normally would under Jetpack Compose or Swift. It's the same analogy. Now let's come back to the Pocket Goods database And let's add another function. Stream user is going to return iObservable of type resource of type user. As usual, we're going to load the query. Next, we're going to return user observable as observable and select. All right. First of all, we have to take the first element from the conversion of user to user model, and we have to return the resource of type user of type success under this variable current user list of users. All right. We're just going to take only one user from the list of users, first or default, and we have to convert it to model. And we have to return resource of type user because it's nullable. It's going to be of type success, and we have to pass as an argument the current user. As simple as this. And add here the new keyword. With the same principle, we're going to stream the application settings reactively from the database. As usual, I'm going to add application settings, entities, and load. Then I'm going to return application settings observable as observable and select. I'm going to name this list to settings. We have to convert basically the first emission to the model. Otherwise, because it's null, the first time we're going to run the application, we won't have the settings saved under the database. Therefore, we have to provide the default settings equal settings first or default to application settings mapper. Because it's null, we're going to have to assign a default or a fallback value, which is application settings and default. And finally, we're going to return the new settings. As you can see here, it's very intuitive. And that's all we have for the implementation of PocketGoods database context. Next, we have to apply the migration to create the database schema by running this command. It's going to create and initialize the migration. And under the migrations folder, the generated migration files will appear in the migrations folder. Right now, we are ready to test our database. So basically what we have to do to create a test, we need to create a test project by running this command. After doing this, we have to add it to the solution with this command, hit reload and save. And we have to test projects right here. All right, I don't like this name, so I'm going to delete this. I don't like how it's named. I'm going to start from scratch. Instead of PocketGoods and whatnot, core and test and hit enter. And we have to add it to the solution. Hit enter and reload. We are testing right now the core module. We have to change the target framework to match the same version under main application. I'm going to copy it from the module. All right, and save the file. For testing, I will install some dependencies. Fluent assertion. Install this package. We need another package, which is Entity Framework Core, because we're going to test our database. And we need in memory version of Entity Framework Core. Make sure to choose this package and install the package. And that's it. And we have to include basically the core module. Add a project reference, check core, and click OK. Save the file, and you are good to go. I'm gonna delete this unit test file. It's gonna be a new class. Let's call it PocketGoods Database Context Test. What we have to do is very simple. We need to prepare the instance of PocketGoods Database Context to test, as usual. And let's add the constructor. In order to construct this database, we need to provide the connection, SQLite connection for the data source memory by doing equal and memory. Next, we have to open the connection and we have to specify the options. I'm going to use SQLite by providing as an argument the connection and call options. And we can initialize the context and we have to ensure that the database is created. Now for the cleanup under dispose, we need to ensure deleted. In other words, we're going to delete the database by doing context and database and ensure deleted. Now let's run the first assertion. We need to make sure that the context is not null. To create a test, add this annotation, fact. Let's name the function by doing context and should not be null. And let's run the test. Click on this particular icon and hit run. You can see here the test in progress. And the test passed. Basically, we have the context created. The next test, we need to make sure that we can read data from the database. Let's say, for example, let's test on the user entity by providing the user entity information. And before moving forward, we have add the mock data to our project. Under util, I'm going to create a new folder. I'm going to call it mock. As usual, it is a static class. It's going to contain the mock data for our application. And let's use this mock data under our project. The test, let's call it can create and read user entity. Let's arrange the user to be added from the mock data, and let's arrange the user entity. Basically, we're just going to convert the user DTO to the user entity. Next, we have to act by doing await and context, user entities, add async, and you have to pass the user entity as an argument. Next, we have to save changes asynchronously by doing async, save changes async. Next, we have to make sure that we can read and context user entities, find async, and we have to provide the user ID from the DTO or from the user entity. It doesn't matter. Next, we have to assert. Let's make sure that the retrieved user is not null. And we have to make sure that they are equal by doing user DTO equivalent to retrieved user. That's pretty much it for this test. Let's run the test. And the test passed, which means that we can read from the database. Now we need to make sure that we can create all the tables. Maybe this particular test should precede this one, but it doesn't matter. What we're going to do here, we're going to check in memory provider does not enforce real database schema. However, we can test basic CRUD operations for each DB set by doing context, user entities, and should not be null. All right. Likewise for products, app settings, image entities, and wishlist item entities. Let's run the test. The test passed. So far, so good. Now we need to make sure that we can insert the data. This is optional, if you will, but I would like to proceed with more complicated tests, including the relationships and whatnot. In order not to repeat the same process every time, I'm going to create here a private async function. Let's call it seed database. We're going to use the user DTO. We need to add the images first, then the products, then the wishlist. Let's do await and context. After that, we're going to add this seeder or the seed user data under the mock data. It's way better. User DTO to user entity. Next, we have to insert the wishlist items by doing for each wishlist item DTO. Let's get the product detail first. Let's store it under product detail. If it's not null, we're going to insert this particular product. We're going to add the products first to product entity. Now we have the products. We can insert the images. For each image, let's call it image DTO instead. Await contacts, images, entities, async, add async. Here it has to be image DTO to image entity and ID. After inserting the product detail and its related images, we're going to insert the wishlist item and context, and the proposition is correct. This is very helpful. After for each loop, I'm going to fold this section. We have to call here await and save changes asynchronously. Now we can make this function reusable, as I said before, by passing here the context, pocket goods database context, and let's name it context. I'm going to fold this. I'm going to copy this particular function. I'm going to add it under mock data, a public, and it has to be static. Now in our test, what we have to do first, await and mock data, and let's seed the user data by providing the context. Visual Studio has done too much. Next, we're going to get the user entity by its related ID from the DTO. Let's arrange the user entity from the database, and we have to call here user data query, first or default async, and we have to look for this particular user by providing user DTO.id. Now for the assertion, we need to make sure that this user entity is not null. Next, we need to make sure that the ID matches the user DTO. Of course, the user DTO ID. Next, we have to make sure that we have the exact same amount of wishlist items from the user entity and the user DTO. And let's do individual assertions under the wishlist item entity. We need to make sure that the item entity should not be null, as suggested here, which is very helpful. Next, we need to make sure that the item entity, more specifically the product's ID that belongs to the item entity, should be the same as the item DTO product's ID. And the product title matches, and basically what we are doing here, we are trying to see if we have the exact same data. The product's ID and the title and the images as well as the other properties, if you will. Next, we have to do the assertion on the images. Images, original images, by doing item, DTO, product detail, which is nullable, media, and select. We have to take only the original images and original. Otherwise, it has to be an empty array. Now we have to do the same thing for the entity. Now for the assertion, it's going to be very easy by doing DTO images and should equal to saved images. That's all for this test. Let's run the test. And the test passed. Now we have to make one important test, which is for the stream of data. We're going to make sure that the function stream user should emit user then null after deletion. This function is very crucial because without this, we cannot handle adding and removing a product from the wishlist. All right, let's insert some data in the database and let's arrange the latest value that's going to be emitted from the stream. Let's call it latest user, and it has to be nullable. Now I'm going to store the subscription under a variable by calling context stream user as shown here and subscribe, which is correct. This is very helpful for the cleanup purposes. Just this, it's not mandatory, but it's optional. Now we have exit by calling this stream user, and we have made the arrangement for our test. Now it's time for assertion. We're gonna make sure that latest user is not null. Next, we're gonna make sure that the name of the user matches the name of the user under user DTO. And I would like to make sure that, for example, the first wishlist item matches the first wishlist item under the user DTO or mock data. This is the first element, which is nullable, by the way. We can access the product detail, which is nullable again, and preview URLs. Let's just take the first one. This whole thing should be exactly the same thing under the mock data. Now we have to ask one more time, basically by deleting the user from the database. I'm going to arrange here the user to be deleted. It is await and context user entities first or default async. And let's remove this particular one. Now we have to save the changes. That's correct. The autocomplete is very helpful. After doing this, we need to load the relationship or the query that we have implemented earlier from context and user data query and to load. Next, I'm going to add a small delay, 100 milliseconds will do. Next, we have to assert that the user was updated to null after deletion by doing latest user and should be null. This is very helpful. Correction and dispose, which is a very good practice. All right, if this function is working perfectly fine, it means that the stream user is working correctly. And under our UI, it's going to reflect in real time the changes, which is what we are looking for. Run the test. Congratulations, the test passed, and I'm very happy with this. Just one important thing to do before moving forward, I would like to run all tests. Click on this and hit run. Basically, all the tests does not interfere with each other, which is good. I think that's pretty much it for this video. For the next video, we're going to implement the API service as well as the crypto service. I hope you have learned something new. See you in the next one, and happy coding.